Hi everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to be talking about weight, mass and gravity and how they're connected to one another by using a bit of maths and doing some calculations for GCSE physics. So if you do enjoy the video, feel free to give it a big thumbs up, share it with someone else, and please do subscribe so you don't miss any uploads from me. We're on paper 2 content at the moment, so thank you so much if you have subscribed. It's lovely to have you as part of our community here, and let's keep this community growing and growing, full of students who want to get better grades. So let's talk about this topic. First off, by looking at a misconception, we need to know that weight and mass are not the same thing. And in everyday language, we kind of use these words as if they do mean the same thing. However, in science, you need to be really careful that you don't mix them up, because when we do use the calculations and the equation we're going to use later on, you need to know about the specific units, and you also need to be able to express your answer correctly. So we want to make sure we understand. So weight is a force, meaning that it's measured in newtons, and because it's a force, it's actually a vector quantity. This just means it has magnitude or size and direction as well. Mass, on the other hand, is a scalar quantity, and this just means it has magnitude only, so no direction, and it's measured in kilograms. However, you can see that they're actually connected by this idea of gravitational force. So weight is mass due to gravity. And if we look at some examples here, we've got a little dog astronaut, and he is on different planets, and you can see his mass remains the same throughout. So his mass is 6 kilograms in every situation. However, the force acting on him due to the gravitational field changes his weight each time. So depending where you are in space will depend how much force of gravity you would experience, or this little dog experiences. So you can see the weight changes depending on whether he is on Earth or Saturn or Jupiter or Mars or wherever else in the universe. And we have to kind of understand that idea that mass stays constant, whereas weight changes due to that force of gravity. So let's have a look at some ideas that we need to explore further. And the first idea is using the equation W equals mg, or weight is equal to mass times gravitational field strength. And you need to be able to recall this equation, but also rearrange it to make mass or gravitational field strength the subject as well. So I've got those different versions of that equation, those rearrangements for you there. Remember that weight, like I said, is a force. It's always measured in newtons. Mass is measured in kilograms usually. It can maybe be expressed in grams. You may have to convert between the two. And gravitational field strength is a combination of mass and weight units. So you can see gravitational field strength is just the newtons divided by kilograms, or newtons per kilogram. That forward slash mark just means a division sign. And you can see that if you're ever in an exam and you don't know what the units are, if you know the equation, you can actually figure out the units. So gravitational field strength, if you look at the equation, you can see is weight divided by mass, which is why the units are newtons per kilogram, or newtons divided by kilograms. You can actually work that out if you get stuck. Just remember as well, something to mention, because they do like to ask this in the exam. How they're related is through an idea of directly proportional relationship. So the weight of an object and the mass of that object are directly related, and they're directly related through this idea of proportionality. So if we increase the weight of an object, we also increase the mass. They are directly proportional, and you can actually express this on a graph by drawing a linear line through the origin, and that shows that directly proportional relationship. And lastly, you've probably guessed by this point, if you've been subscribed for a while now, if you type it, you must write it. That's kind of my saying here on YouTube. Always make sure you show you're working out. Lots of students that I teach will often type in the answer in the calculator, get the correct mark, or get the correct answer, I should say, and don't get the marks for working out. Because sometimes, if you're in the exam, you're in a high pressured state, you might misconstrue what you've written in the calculator. And if you do that, you want to make sure that your working out shows that you knew what you had to do. So just make sure if you type it, you write it as well, just to make sure you get those marks. So let's have a look at some calculations then. We've got 3 different questions because we've got 3 different versions of using this calculation or this equation. So the first question says the strength of gravity at the Earth's surface is 9.8 newtons per kilogram, which is correct. Actually, it's factually correct. Calculate the weight of a car when it has a mass of 1,500 kilograms. So all you need to do for this question is to write out the equation first. We're calculating the weight, so it'll be W equals M times G. You've got 1,500 because it's already in kilograms, and you're timesing it by 9.8, and you should get an answer of 14,700 newtons. Remember to underline your answer, make sure the units are correct, and then you can show that working out really clearly to the examiner. The next question, it says, if an astronaut's weight is 850 newtons, what would the mass be on the moon if the gravitational field strength or the strength of gravity on the moon is 1.6 newtons per kilogram? Again, you want to write out the equation. We're being asked to calculate the mass of the object. We are doing mass is equal to weight divided by gravitational field strength. You pop the numbers in. So weight is 850 divided by 1.6, and you get an answer of 531.25 kilograms. At this point, I would say it may be worth rounding this answer to 531.3 kilograms, as the answer needs to kind of reflect what number of decimal places the question has in it. So you can see 1.6 is given in the question, so you might want to just round it to one decimal place. It hasn't asked for that, but they could do that in the exam. They could also ask for significant figures. They could also ask for it to be written in standard form. It's worth being aware of how to do that, especially if you're a higher tier student. And if you would like more information on how to write answers or calculations in standard form or anything like this, do let me know in the comment section. I'm more than happy to make a video or a short on it to help you out. So the third question, it's asking us if a rocket had a weight of 38,700 newtons and its mass is 34,000 kilograms, which is very, very big, on planet X, what is the strength of gravity? So we can do this by using the equation G equals weight divided by mass. And we're just going to pop those numbers in again. So we've got 38,700 divided by 34,000, and we get an answer of 1.14 newtons per kilogram. Remembering the units, underlining it, showing the process, the steps to get to that answer as well is really, really important. And then last but not least, here are some questions that are for you. So the first question, same exact thing, but what if the car now had a mass of 1,850 kilograms after a few people and all their bags and everything were inside? What about for question 2? What if a different astronaut was on the moon with a weight of 870 newtons? Can you calculate the mass? And for the third question, what if the mass was now 35,500 kilograms? Calculate gravitational field strength. So do have a go at those questions. Write them in the comments below. I'd love to hear from you. Don't forget to show your working out and your units as well. And that's it from me today. Thank you so much for your time and watching. I've been the GCSE science teacher and you have been curious. If you did enjoy the video, please do give it a big thumbs up. It does help my channel out and it lets me know if you are enjoying these videos so I can make more of them. Also, if you haven't already, do feel free to subscribe, share this channel with someone else or even this video with someone else so they can also learn too. And let's build this community. It's already fast growing. I'm so excited that we are all learning science together. So if you are enjoying it, feel free to join our community by subscribing. If you want more videos from me, I have lots on YouTube. So if you want playlists for paper 1 content, I am also currently making paper 2 content. So if you want biology, chemistry or physics, have a check on there. I have links on videos at the end as well. You can click on now. But also if you want shorter bite-sized revision, check out my Instagram and TikTok. Everything is at the GCSE Science Teacher. So hopefully you'll be able to navigate to it. If you need help, go on my channel and you'll find the links are all there. Thanks so much and I'll catch you in the next one. Take care. Bye.